Hello everyone, my name is Amol More and you are watching Solution to Black Book channel. Now today we have gathered here to understand a very interesting property of complex numbers. So this session is dedicated to the magic of complex numbers. Okay, so the simplest property of complex numbers which all of you know that if x plus y is equal to a plus ib, then you can compare the real parts and the imaginary parts. It means that x should be equal to a and y should be equal to b. That's it. So simple. But most of the students get bored using this property. Sir, what's the use of this? This is so simple. But today we are going to understand the magic which lies behind this property. Okay, so in order to understand the magic which lies behind this property, I would like to remember you or make you remember some of the trigonometric formulae. Okay, so what is the formula for sine 2 alpha? 2 sine alpha cos alpha. Very good. And what is the formula for cos 2 alpha? It is cos square alpha minus sine square alpha. And you have even proved this. Okay, so just make a note of it that the formulae of sine 2 alpha and cos 2 alpha are known to us and we have proved them by using compound angle formulae. Okay, then there is one more thing which we know. If we have cos of theta plus I sine of theta, then using Euler's form, we can write down e raised to I theta. E raised to I theta comprises of cos theta plus I sine theta. Now suppose if I raise both sides by a power n, what will happen? So e raised to I theta the whole raised to n. So left hand side remains the same, but if you can check the right hand side, it will be e raised to I n theta because of the laws of indices. But e raised to I n theta can be written as cosine theta plus I times sine of n theta. And check the left hand side, it is cos theta plus I sine of theta raised to n. So let us box it. Now you will say, sir, we know this property. This is the property or this is a theorem called as de Moivre's theorem. So let me write down de Moivre's theorem. Okay, so what's new in this, sir? Okay, so let us get back to our idea of the session. We had seen that if two complex numbers are equal, then their real and imaginary parts can be compared. Then we had seen cos theta plus I sin theta is the representation of a complex number and in Euler's form is e raised to I theta. Then we understood de Moivre's theorem. Cos theta plus I sin theta raised to n is equal to cosine theta plus I sin n theta. Okay, so let me say that cos theta plus I sin theta raised to 2. Then instead of n, I am putting n as 2. So to the right hand side also, it will be cos of 2 theta plus I sine of 2 theta. Now to the left side, we can expand this. So this will be cos square theta plus 2 cos theta sine theta into I. A square plus 2ab plus b square is equal to cos 2 theta plus I sine 2 theta. Now check the left hand side, this will be cos square theta and I square will be minus 1. So this will be minus sine square theta and then this will be 2 cos theta sine theta I, which is equal to cos 2 theta plus I sine 2 theta. Now let us compare the real and imaginary parts. On the left hand side, the real part is cos square theta minus sine square theta and on the right hand side, the real part is cos 2 theta. Therefore, cos 2 theta is equal to cos square theta minus sine square theta, which is our actual formula. And to the LHS, just check out the imaginary part, which is 2 sine theta into cos theta. And to the RHS, the imaginary part is sine 2 theta. So again, we got the formula for sine 2 theta also. So we basically got the formula of cos 2 theta and sine 2 theta by using complex numbers. Now let me amplify this further. Suppose if I put n as 3, then what will happen? So cos theta plus I sin theta the whole cube and then it will be equal to cos 3 theta plus I sin 3 theta. By now you might have got the gist of this session, that what we are actually going to do. So a cube plus 3a square b plus 3ab square plus b cube. Okay, I'm not writing down the RHS. RHS, as we all know, is cos 3 theta plus I sin 3 theta. Now I will write down all the real parts. Let us check out the real parts. So real part is cos cube theta, and then this I square will be minus 1, minus 3 cos theta sin square theta. Okay, that's it. This is the real part. And then if I take I common, what will happen? I cube is actually minus I. So this will be 3 cos square theta sin theta minus sin cube theta. Okay, so you can check, this is the imaginary part. Let us check out once again. 3 cos square theta sin theta, I cube will be minus I, so it will be minus sin cube theta. Now let us compare the real parts and the imaginary parts. So therefore comparing real part, cos 3 theta will be equal to cos cube theta minus 3 cos theta sin square theta. Now as we all know, sin square theta can be replaced as 1 minus cos square theta. So what will happen? So this will be cos cube theta minus 3 cos theta plus 3 cos cube theta. So cos cube theta plus 3 cos cube theta will be 4 cos cube theta minus 3 cos theta. So we got the formula for cos 3 theta as well, which is 4 cos cube theta minus 3 cos theta. Now let us compare the imaginary part. Sin 3 theta is equal to, so let me write that down on the next part. Sin 3 theta is equal to, what is the imaginary part? 3 cos square theta sin theta, 3 cos square theta sin theta minus sin cube theta. So it will be minus sin cube theta. So cos square theta can be written as 1 minus sin square theta and sin theta minus sin cube theta. Let us multiply. We will get 3 sin theta minus 3 sin cube theta minus sin cube theta. So this will be equal to 3 sin theta minus 4 sin cube theta, which is equal to sin 3 theta. Okay, so see how simple was that? By using complex numbers, we have actually derived the formulae cos 2 theta, sin 2 theta, cos 3 theta and sin 3 theta. You can even derive the formula for cos 4 theta, sin 4 theta, cos 5 theta, sin 5 theta and so on. I would like you to try this for sin 5 theta and derive the formula for the same. So if you derive the formula for sin 5 theta, you will also get the formula for cos 5 theta. So please do this by using this magic of complex numbers, and do comment your answers in the chat box so as to know that your answers are correct or not. So in today's session, we have understood one of the magics of complex numbers and how complex numbers simplifies trigonometry. Thank you for watching the video guys, and do not forget to like, share and subscribe to our channel.